Hello, this is Nikki Jackson from Southwest Tennessee Community College, and this video is going over the different type of logarithm functions and exponential functions for Math 1710. So here are just several examples if you see already. Hopefully you were able to jot down a quick few notes from stcc.mylabs Plus dealing with the particular properties of logarithms and exponential functions. So let's look at number 1. So with this particular example, this is what's provided for you. So you have this right here, the natural log of x plus the natural log of 10. Well, since this is a particular property, when you see addition for natural log, you automatically assume multiplication. Hence, the final answer is going to be the natural log of 10x. So again, when you see the addition, that's going to be the multiplication. Your next one that we have is going to be 4 to the 4x minus 5 power equals 64. So what's going on right here, we're trying to figure out what to do in order to solve for that particular equation. And somehow I have misplaced that. Here we go. So my apologies for the delay. So here we go. So what we're trying to do right here, we know that 64 is something dealing with an even number. And just know, because you know your multiplication and you're looking at what's in the ones place, we're going to think about 4. Plus, this right here is a base 4. So what can we do to 64 that have a base 4? Well, 4 to the third power actually gives you 64. So notice how you have both the bases right here. So now since we have the same basis, we can use it as an equation. So you can simplify that as 4x minus 5 equals 3. Now we're going to solve for x. The 8 came from adding 5 to both sides. So now we have 4x equals 8. Now divide both sides by 4. Your x equals 2. Your next example is still dealing with an exponential function. And it wants to know what the solution set is. So once again, the goal is to find the like basis. So with this particular one, again we have 64, but your base given to you is 2. So 2 to the 6th power gives you 64. Notice how the bases cancel out right here. And now we have x equals 6. But here's another example of a logarithm function. Now you're going to use the rules pertaining to the quotient rule. So remember earlier when we did the addition, that was multiplication. When it's a fraction, that is pertaining to division. Therefore, when it's division, you're going to subtract. So we did the log base 2 with 8 as your numerator. Then we do the log base 2 with x plus 7 square root of that. Now notice right here, we can rewrite the square root as the same thing as the 1/2 power because we want to make sure that we keep this as an exponent. So bring this down right here. So we know that 2 to the 3rd power gives you 8. Right here, we're going to multiply everything by the 1/2 power. Again, this is dealing with one of the properties. We can't simplify this, so we're just going to bring all of this down. But back to this part right here. Think about when you had the base squared. In other words, 2 to what power gives you the 8? So we know that 2 to the 3rd power gives you 8. Hence, this can be simplified to 3. And all of this is your final answer. We have another one dealing with logarithms. This example here. So let's look at number 5. Notice how 5, 6, and 7 are all pertaining to either your log or your natural log. So going to number 5 now, we're going to use the derivative of this to a certain extent. So notice how you're multiplying everything by the exponent on the front end. When you do this, the exponents cancel out and now they become a coefficient. So your final answer is -2 log B. When you do your next one, this is very similar to what we did in 3.1, converting your logarithms to exponential form. Or another way of saying that is like 3 to the second power is 9, because we know that 3 times 3 is 9. So when you rewrite it in exponential form, this is what you have. Then we have a natural log. Now we have natural log e to the 7th power equals 7. Well, be mindful that natural log and the exponential e, which is in your calculator, they kind of cancel each other out. Therefore, your answer is just 7, because you're going by what's actually given to you. Then we have number 8. Given to you is log base g of 13 equals 11. So my apologies for that little typo right there. Remember earlier when we did a previous example, when you see multiplication, that means addition. So when we split this using distributive property, or the opposite of distributive property, we have log g13 plus log g11. Now with number 9. This is a little tricky, so make sure you have your calculator handy. With this particular one, we want to solve what the exponent x is. Well, again, we have to have our calculator. The first step you do is take the natural log of both sides of the equation. My handwriting is kind of sloppy right here, but that's the LN. So now we have the natural log of 3 to the x power, then the natural log of 113. Multiply on the left-hand side by your exponent x. So now you have x natural log 3 equals natural log 113. Divide both sides by natural log of 3, and we're going to see how we get the answer to 4.3. Now, when it's your turn to do it, make sure you read your directions carefully to what particular decimal place it wants it to be. So we're going to do, let me zoom out so you guys can see it. So we're going to do natural log, which is ln, 113. Make sure you close your parentheses. Different versions of the calculator may or may not have with parentheses. Divided by natural log 3. And I always close my parentheses if it's given or open. Hit enter. And again, make sure you read your instructions carefully to see which decimal place. So in this one, it's actually needed 2 decimal places, so now we have 4.30. So here's another example of a log. So I'd like to reword it so I can better understand it. So 17 to what power gives you 13? Well, since that's 13 is smaller than 7, you already know that the exponent has to be either a fraction or a decimal. The easiest way to do that is to find the natural log of 17. Notice how I just rewrote both of them. So what power gives you 13? Natural log. Then you multiply on the left-hand side by x. And to solve by x, divide by the natural log of 17. So let's see how we got that. So I'm going to hit the natural log key in. Put 13, close parentheses, divided by natural log 17, close parentheses. And pay close attention to what is being asked for, what decimal place. Since it's asking for 4 decimal places, oops, you can't see that. We have 1, 2, 3, 4. Behind that 3 is just a 1, so it doesn't round up. So your final answer is 0.9053. Once again, be careful when you actually round it on your turn. Now lastly, it wants you to use the properties of logarithms to expand this. So given to you, you have log base 12 of 12 divided by y. Now remember, this is dealing with the quotient rule. If you see division, it's subtraction. So now we got log base 12, which is 12, minus log base 12, y. Well, since your base and your number are the same thing, that automatically makes it 1. You can't simplify this part because you don't know what y is. So now your final answer is 1 minus log base 12, y. So once again, thank you for tuning in, ladies, gentlemen, individuals, and continue to do a great job working diligently in Math 1710.